Hi, in this video we're going to look at areas and tangents, all to do with straight line graphs. First, basic skill of how to work out the area of a triangle given its various coordinates. So you ought to know that for any typical triangle we can just do half base times height. That's what we're going to use here. So for each of these questions we want the triangle enclosed by the points A, B, C. So that gives me this triangle here. And if I sort of use the triangle on its side, I can work out its base, which is going to be from -2 to 4 is 6. And its height, we can see, is from 0 to 2, which is going to be 2. So plugging that into my formula, we've got a half times 6 times 2, which just gives an area of 6. For these questions, unless you're told otherwise, there's no units to go with this, because we don't know how long each length is going to be. Okay, let's see that again. So again, we've got 3 coordinates, and we can see our triangle fits nicely inside all of those. So here we can see the base is going to be 8 across, and my height is 1.5. So we do a half times base times height. Typing that all in, that is going to give you an area of 6 again. So that's the most basic idea. We can see it's sort of used in a couple of different ways. So first we're going to see that is having to use perpendicular lines. So we've got a right angle triangle, which is clearly we need to use perpendicular lines, and we need to find the area of the triangle enclosed by the points A, B, C again. So first thing I need to do is work out these missing coordinates for A and for C. Once I've got those, I'm going to do the same trick as before, just do half base times height. C, we can see straight away from this y cut of 11 is just going to be 0, 11. To find A is slightly harder, we're going to need the equation of this line. Now we know for this line, looking at the equation of it, that m is -1/2. So therefore by taking a negative reciprocal, we see the gradient of this line is going to be 2. So we have y equals 2x plus something. We also know it must go through the coordinate b, so we can plug that in, which tells us 9 is 2 times 4 plus c. 2 times 4 gives us 8, and there we can see c is 1. So the equation of this line was y equals 2x plus 1, which tells me that this y coordinate is 0, 1. Then same trick as before, we can see that this length, I'll call that my base, is going to be 10, and this length, my height, I'm looking at the x coordinates, if I'm going along, is going to be 4. So the area is just going to be 20. Half times 10 times 4, which gives us 20. Okay, main thing we're looking at, the main thing to be used with, is tangents to circles. So explain what it is really quickly. Here I've got my circle here, and this line is a tangent line. That means it touches a circle, but it doesn't go through it. It sort of glides as it touches it and then moves on again. So we're going to see how we can find a tangent to a circle. So you're basically going to follow these 3 steps. I'll go for more depth in a second. Before I do that, just a quick recap, because sometimes comes up, is finding the equation of a circle. You should know that any equation of a circle is just based on Pythagoras. It's x squared plus y squared equals r squared, where r is the radius. If we want to work out the equation, all we need to do is plug in any point that lies on that circle. So plugging in 3, 2, we have 3 squared plus 2 squared. 3 plus 3 plus 2 squared is 9 plus 4, which is 13. So therefore 13 is r squared. So the equation of my circle is x squared plus y squared equals 13. And this radius here will be root 13. Okay, so let's go on to the main question. We're going to find the equation of the tangent at this point 3, 2. So drawing that on, so that's going to look something like that. And again, we're going to follow these same 3 steps. First step, we're going to find the gradient of the line from the centre. So what I mean by that is, if I drew a straight line, from the centre, what would that gradient be? That we can see really easily. We can just use this coordinate, or we can use the formula m is y2 minus y1 over x2 minus x1. This one's really easy because I'm going from the origin. So if I call that x1 and y1, I'm just left with y2 over x2, which is going to be 2 over 3. So the gradient of this line is just 2/3. Now, it's a fact that I'm not going to show right now, but you can prove it quite straightforward, that any tangent is always perpendicular to an equation, to a line straight from the centre. So that means because we can work out this gradient quite easily, we can now use that to work out this gradient. So taking a negative reciprocal, this gradient is going to be minus 3 over 2. And now I can find the equation of that line, which I want to do. So y equals mx plus c. Plug in the coordinate we know. And then we're just going to solve that to work out what c is. And again, that's fairly straightforward to solve. And then once we've done that, we now have the equation of our tangent line. So this is pretty much like, almost like the grade 9 level in terms of difficulty for how hard straight lines go. But if you sort of break it down into each of its small chunks, which in previous videos, it's really not the worst thing in the world. So we're going to go through a few examples like this and sort of see how it gets a tiny bit harder, and also how it's going to incorporate the area stuff as well. So same idea, I want the equation of the tangent at the point minus 1, 4, which is here. It's going to look something like that, kind of. So, first step again, we need the gradient from the centre. Add this line in here. To find this m is going to be y2 minus y1 over x2 minus x1. So 0, 0, they're my x1 and my y1. And my x2 and y2 are minus 1 and 4. So plugging this in, we get 4 over minus 1, which gives us a gradient of minus 4. Again, any tangent will always be perpendicular to the line straight from the centre. So we know this is a right angle, which means if this has a gradient of minus 4, this will have a gradient of a quarter, because that's a negative reciprocal of minus 4. Then it's the same trick as before. We're going to take this, write down y equals mx plus c, plug in the coordinates, and then we can see that c is going to be 17 over 4. So therefore this is the equation of my tangent. And again, all I've done there is just followed these 3 steps. Gradient from the centre, that was finding this minus 4. I then took the negative reciprocal to give me the gradient of my tangent line, and then I plugged in the coordinates minus 1 and 4 to work out my value of c. And that was it. Okay, on to the main questions. So here in this question, we want the area of the triangle ABC. So let's draw that in really quickly. That means if I had this triangle, what would its area be? And again, just like in the first few things I went through, what we need to work this out is going to be the 3 coordinates A, B and C. So A is obviously the origin, so that's 0, 0. And C we don't know. C we're going to work out. We can do that using the exact same steps as before. So first you find the equation of the line. In actual fact we did this for this equation here. So it's the same question. And here the equation of this line is y equals minus 3x plus 13 over 2. So that is the equation of that line. And we can use that to work out c. So we know c is on the x-axis. So therefore we know at the coordinate c, the y-coordinate must be 0. That's what being on the x-axis means. So plug that into our equation. We've now got 0 equals minus 3 over 2x plus 13 over 2. And I can double my entire equation. So 0 equals minus 3x plus 13. I'll take the 3x across and then divide everything by 3. And I'll just keep my answer as a fraction. So we've done that. That means we now have this missing coordinate. That was 13 over 3, 0. Then just the first thing we went through, we're going to do a half base times height. The base is from here to here, that length is 13 over 3, and the height is this length, that length is 2. So it's a half times 13 over 3 times 2, which simplifies down to just 13 over 3. And that is the area of that triangle there. Okay, quite a lot going on there. The key thing to get good at these questions is to break it down to each of its steps. Do one little bit at a time and try not to sort of think too far ahead until you get to that stage. Let's see that idea again and see if I find it any easier this time. So, same setup. We've got a circle, we've got one point of circle, we have a tangent line, we need to find the area of this triangle. So again, we're looking for all three coordinates, A, B and C. B you're given. A is obviously the origin, so it's 0, 0. We need to do the hard work in finding out the equation of line C. So let's go through these steps. First step, gradient from the centre. So this gradient is going to be y2 minus y1. That is 4 minus 0, because that's y2 and that's y1, over x2 minus x1. And simplifying this down, this gives us a gradient of minus 2. Okay, so that's the first thing I do. I find the gradient from the centre. Now remember, this is always a right angle, so we can now use that to find the gradient of this tangent line by taking the negative reciprocal. So the negative reciprocal of minus 2 is going to be plus a half. Now we need to find c in terms of y equals mx plus c. So y equals a half x plus c, and we know it has to go through this coordinate, minus 2, 4. So let's plug that in. So 4 is a half times minus 2 plus c, and solving that we're going to get c equals 5. Okay, we found the equation of that line, and again we're now going to use this to work out the coordinates of point C. Just as before, C is on the x-axis, therefore it means the y value is going to be 0. So what I'm going to do, I'm going to take this equation and I'm going to solve it with y being 0. So just copying this equation down up here, I've now got 0 equals a half x plus 5. So let's go and solve that. First I'll take the 5 across, so we've now got minus 5 equals a half x. I then want to get to my fraction. Opposite divided by 2 is times in by 2, which tells me that x is going to be minus 10. So I now know this coordinate for C. That is minus 10, 0. Now we've got that, it's fairly easy to find the area of this triangle. So the area is a half base times height. This base is from here to here. We can see that length is 10. Again, the factors of minus is irrelevant, because all we care about is how long it is, not whether it's positive or negative. We then need this height, and that is 4 squares high. So the area is a half times 10 times 4, which gives us 20. And that's it. That's basically the last thing you should know with basic straight line graphs. Okay, hope you found that useful, and thanks for listening.